Have you ever looked up at the moon and wondered about its origins? It's a question that has captivated humankind for centuries. The pale, silvery orb that graces our night sky has been the subject of countless myths and legends, each more fantastical than the last. Yet the true story of the moon's creation may be even more extraordinary than any tale spun by ancient storytellers. Imagine the early solar system, a chaotic dance of dust and gas gradually coalescing into the planets we know today. But our own planet, Earth, held a secret, a companion perhaps lurking in the shadows. The moon's formation has been a conundrum wrapped in layers of scientific investigation and hypothesis. The most compelling of these is the Theia Hypothesis. This theory paints a picture of a violent past, of cosmic bodies clashing in a ballet of destruction and creation. What if I told you our moon might be the product of a catastrophic collision? Enter the Theia Hypothesis, our best scientific guess at the moon's violent birth. This theory, as intriguing as it is, paints a picture of a cosmic cataclysm that ultimately gave birth to our beloved lunar neighbor. The Theia Hypothesis proposes a scenario where, in the early stages of our solar system, the young Earth had a dramatic encounter with a celestial body the size of Mars. This rogue planetoid, now known as Theia, was wandering through the galactic neighborhood when it crossed paths with Earth. This wasn't a gentle meeting, mind you, but a high-speed, head-on collision. You might be wondering what happens when two celestial bodies collide. Well, the impact was so intense that it melted and vaporized a significant part of both Earth and Theia. This led to a storm of molten and vaporized rocks swirling around Earth in a ring-like formation. Over time, this debris began to coalesce, slowly forming a new body in the night sky. This body is the moon that we gaze upon today. Let's take a moment to appreciate the scale of this event. We're talking about a celestial smash-up that was so powerful it could melt planets. It's an event of such grand proportions that it's hard to wrap our minds around. Yet this violent beginning is what gave birth to the tranquil and serene moon that we know today. So what happened to Theia after the collision? Well, it's believed that Theia didn't survive the impact in any recognizable form. Instead, it was absorbed and integrated into what became the Earth and the Moon. In essence, Theia sacrificed itself so we could have our natural satellite. It's a fascinating theory, isn't it? The idea of our moon born out of a violent cosmic collision. It's a testament to the incredible forces at play in our universe and the extraordinary beauty that can arise from chaos. So, how does this catastrophic event unfold? Let's dive deeper. Imagine early Earth peacefully existing when suddenly a rogue planet named Theia enters the scene. This isn't the setup for an epic space opera, but rather the reality of our planet's tumultuous past. Theia, an astronomical body nearly the size of Mars, was on a collision course with our nascent Earth over 4.5 billion years ago. This wasn't a mere fender bender or a gentle graze, this was a full-on, high-speed, cataclysmic collision. The impact was so monumental that it could be likened to a cosmic car crash in slow motion, unfolding over millions of years. Now imagine the colossal energy released during this event. It was so immense that both Earth and Theia did not merely shatter into pieces, they melted. Picture the sheer power required to liquefy entire planets. It's a concept that's hard to wrap our minds around. This wasn't a disaster, though. Quite the contrary, this was a rebirth. From the molten wreckage of this colossal crash, a new, larger Earth began to take shape. Theia and Earth, once separate entities, had merged to form a single, unified planet. This new Earth wasn't alone, though. Amid the swirling debris and molten matter, a smaller mass began to coalesce. It spun off from the main body, trapped in Earth's gravitational pull. Over millions of years, this mass cooled and solidified, eventually becoming the celestial body we now lovingly refer to as our moon. This cataclysmic collision wasn't an end, but a new beginning. It was a pivotal event in the history of our planet, one that played an instrumental role in shaping the Earth-Moon system we are part of today. But what about our moon? Where does it fit into this cosmic drama? Well, stay tuned, because the birth of the moon is an equally thrilling tale as it rose from the remnants of this cosmic catastrophe. In the aftermath of the collision, a small part of the new mass spun off into space. This wasn't just any ordinary space debris. This was the beginning of something extraordinary. The birth of our moon. Imagine the scene, if you will. Our young Earth, still reeling from the impact of the cataclysmic collision, was surrounded by a ring of molten rock and debris. This was no ordinary ring, but rather a torus-shaped cloud of dust and gas spinning rapidly around the Earth. Now you might be wondering, how did this molten debris turn into the moon we see today? Well, it's all thanks to gravity, our silent and invisible cosmic sculptor. Acting like a master artist, gravity began to slowly mold this debris cloud. Over time, smaller bits of debris started sticking together, forming larger and larger clumps. This process, known as accretion, continued for millions of years. As these clumps grew in size, their gravitational pull also increased, attracting even more debris. They grew and grew, forming what we call moonlets, mini-moons if you will. Eventually, one moonlet became dominant, its gravitational pull so strong that it swept up all the remaining debris in its path. And voila, what started off as a ring of molten rock and debris around our Earth eventually coalesced into the moon we see today. This wasn't a smooth process, though. The early moon was a hot, molten mass, its surface a rolling sea of magma. Over billions of years, this magma sea slowly cooled and solidified, forming the crust of the moon. The scars from this violent birth are still visible today in the form of the moon's craters and basins. So, there you have it, the birth of our moon, a tale of cosmic violence and rebirth. The moon, our constant companion in the night sky, is a testament to the incredible power of the universe and the enduring legacy of its fiery birth. But how can we be sure this dramatic event really happened? The Theia Hypothesis, as compelling as it may seem, is just that, a hypothesis. For it to hold any weight, it needs to be supported by tangible evidence. Fortunately, there are several pieces of evidence that support this theory. Let's dive into some of them. One key piece of evidence lies in the moon's orbit. The moon's current orbit is tilted by about 5 degrees relative to Earth's orbit around the sun. This is unusual because if the moon had formed from a disk of material rotating around the Earth, as some earlier theories suggested, we would expect the moon's orbit to align with Earth's equator. The fact that it doesn't suggest that the moon's formation involved a more dramatic event, such as a giant impact. Another supporting piece of evidence is the composition of the moon. The moon's rocks have a similar isotopic composition to Earth's rocks. This is quite peculiar because if the moon had formed elsewhere in the solar system and was later captured by Earth's gravity, we would expect its isotopic composition to be different. This similarity suggests that the moon and Earth share a common origin, consistent with the Theia hypothesis. Finally, there are computer simulations. These simulations show that a collision between a Mars-sized body and the early Earth could indeed result in an Earth-Moon system similar to what we observe today. These simulations provide a plausible mechanism for the moon's formation and help to tie together the other pieces of evidence. It's important to note, though, that while this evidence supports the Theia hypothesis, it doesn't prove it definitively. There are still many unanswered questions and other hypotheses to consider. However, the Theia hypothesis provides the most comprehensive explanation so far for the moon's existence, its peculiar orbit, and its similar composition to Earth's rocks. The Theia hypothesis, while not definitive, is our best explanation for the moon's existence. Our moon, a silent witness to Earth's violent past. It's a testament to a cataclysmic event that shaped our world and gave birth to our lunar companion. The Theia hypothesis, a compelling theory that paints a picture of a colossal impact between Earth and a Mars-sized body named Theia. This violent encounter in Earth's early history caused both bodies to melt and reform. A small part of this new mass spun off, setting stage for the creation of the moon. The evidence supporting this hypothesis, from the isotopic similarities between Earth and the moon to the moon's unique orbital characteristics, adds more weight to this intriguing theory. The implications of this hypothesis are profound. It not only provides an explanation for the moon's formation, but also gives us insights into the dynamic and often violent nature of the early solar system. Next time you gaze upon the moon's serene face, remember the violent origins it hides, a testament to the profound and dynamic nature of our universe.